All right, hello once again. This is Jeff Scott of Rankin Technical College. We've been talking databases, and in particular, I've been going over the first two sections, or the first 12 chapters, of the book you see right in front of you. That is the third edition of SQL, A Beginner's Guide by Andy Oppel and Robert Sheldon. And we are in the middle of Chapter 11 of 12. And we left off last time talking about, there we are, creating the cross join, I believe is where we left off. We did joins with more than two tables, talked about that, and I think we left off here. So, in addition to the comma-separated join, SQL supports another type of operation called the cross join. As it says, it's nearly identical to the comma-separated join. The only difference is, instead of separating the column names with a comma, you use cross join or the cross join keywords. All right, so they say, let's take an example here. So from this, cross join this. All right, so let's give this a try. I am not currently logged on to my database, but I'm going to do it right now. So I've started up Apache and MySQL, starting up MySQL from the command line. I'm going to use the Acme database. Okay, so we're just about ready to go here. And I want to use, kind of use what they did. Cut this down a bit here. That's not what I wanted. All right. So last time we did a select. Whoops, that was interesting. Last time we did a select, and I believe what we selected was the first name, the last name, the department number, and the salary. All right, and then we came back and we added, we said if we want to be good database developers, we did E dot here, E dot here, because those are both coming from the employees table, D dot here because that's coming from the department table, and E dot here because that's coming from the employees table. So from employees, E, departments, D, where E dot dept number equals D dot dept number. Just trying to get back into the swing of it to make sure that, all right, so there you see it. So we grab the first name, last name, and salary fields. We grab those three fields from our employees table and the department number field from our department number table. Let's pretty this up just a tad. I don't like those headings, but they're the column names by default. So let's really kind of try to pretty this up a bit. So as first name, as last name, in fact, let's just get rid of this for now. Let's just call this dept number. Cut it down a little bit because it's such a wide column right there. And there, I like that. All right, so we made it look a little bit nicer. All right, so what I want to show you is I want to go back and I want to run the same query, hopefully at least, as a cross join. So I'm going to select the same stuff we did before, but I'm going to have the first the name of the first table, cross-join the name of the second table. All right, so let's see if we get the same results if we do that. So from employees, now this has got to be cross-join, okay? And it says, of course, we have an error in our syntax. And I can see already I did not put a comma there. So let's go back and let's put that comma in. No, I shouldn't have had a comma there. No, let's look. Let's take a look. Select this, from this, cross-join this, where looks to me like it should have worked. Now, so the next thing to do is to check, does my SQL support cross-join? Got join syntax, MySQL cross-join. MySQL supports the following join syntaxes. Well, there's cross-join. Here's an example of a cross-join. So select this from that table, cross-join with the other table. So, looks like we might not need a where statement then. So, let's just try this. Well, we got everything when we did that, so it does support the cross-join, but it gave us every single thing we had in there, so everybody's working for every department. Well, that isn't what we want. And again, there were 12 employees and 6 departments, so 12 times 6 is 72. So let's look one more time. So let's grab this, and this, and this, but let's try to put in the where and see if I can figure out what the problem was. Where E dot depth number equals D dot depth number. There it is. So there was the same query as a cross join. So select our fields from employees instead of comma here, departments D, it was cross join. All right. Now, you might look at that and say, okay, Jeff, that's all fine, but why exactly would we do that? Well, using one over the other may simply be a matter of determining which statement your SQL implementation supports. If both are supported, which provides better performance? In all likelihood, it comes down to personal preference. I like the first one. You can see that I was much more comfortable with the first one. Now, it may be, depending on the relational database management system that you're using, if it's not MySQL, that the cross-join is or is not supported. All right? You also might, if you are running queries that are real-time sensitive, you might have to hook this up to the system clock to see which one runs faster. All right. Self-join. A self-join is when you join a table on itself. Sometimes, believe it or not, that's the only way that you can get the information that you're looking for. Now, in this example, because I don't have a good self-join example, I don't believe, with the database that I've set up. But if we look here, it says the employees table includes a list of employee IDs, employee names, and the employee IDs of their managers. who are also listed in the table. For example, the manager of Mr. Jones is Mr. Smith. The point is, when we create a self join, notice what we're doing here. From employees A, employees B, so we're joining the table on itself. So what we're saying here is if you look at these results, Ms. Smith does not have a manager. All right? And Mr. Jones and Mr. Roberts both report to Ms. Smith. Ms. Hanson reports to Mr. Roberts. So does Mr. Carver. And Mr. Fields and Ms. Lee both report to Mr. Jones. So the idea is, if you looked at the hierarchy, for lack of better words, might make it a little easier to view in this kind of a circumstance, and that is all right, we're going to look at it this way. At the top, we've got Ms. Smith. All right, and who reports to Ms. Smith? Well, directly who reports to Ms. Smith is Mr. Jones and Mr. Roberts. All right, so who reports to them? Well, if we look at it like this, Mr. Roberts, and Mr. Roberts is, we have Mr. Jones and Mr. Roberts. Mr. Jones has Mr. Fields. And in fact, let's kind of, for lack of better words, we'll try to pretty this up. And Ms. Lee. And Mr. Roberts has reporting to him Ms. Hanson and Mr. Carver. So when we look at this and we look at the hierarchy here, this is what's important to realize. This is right here our hierarchy. All right? Now we can draw, I can put little lines and stuff here, and I've done this kind of thing before, not for you, but for classes and stuff that I've taught. So if we look at the hierarchy, we've got on the top of the hierarchy, we've got Ms. Smith. And Ms. Smith, for lack of better words, is the head honcho. Who reports to Ms. Smith? Well, who reports directly to Ms. Smith are Mr. Jones and Mr. Roberts. And who reports to Mr. Jones? That would be Mr. Fields and Ms. Lee. Who reports to Mr. Roberts? That would be Ms. Hanson and Mr. Carver. So sometimes the only way to dig the information out that you need is to go through the table that you're currently working with. All right? So could we do this? Yes, I can come in here if I want to, and if I select star from employees, I could add another column in here that was called manager ID or something like that. And I could have a bunch of people report to me and a bunch report to etc. We could do that. I don't want to, just because of the fact that, to be perfectly frank with you, I'm afraid I might goof it up. All right, maybe I'll try to do that between tapings and then come back and show you what I did. All right? But I want to jump ahead here. Joining tables with shared column names. All right, I'm up to page 280 here. SQL provides two methods for setting up joins that you can use when you're working with columns that have the same name. Those are the natural join and the named column join. In order to use either of these two methods, the tables must meet the following two conditions. The join columns must share the same name and have compatible data types. Doesn't mean necessarily they're the same data type, but they must be compatible. And the names of the join columns cannot be qualified with table names. When you're using either the natural join or the name column join, each table must share at least one column in common. All right, it says I use the table, I describe each of these next. So here is a natural join. All right, so let's use that as an example here and see if we can write a similar type of thing. All right, so let's select, and notice on here, the only field that we have to put something in front of is the one that is in both tables. So let's select first name, last name, now the department number, so we'll use d.depth number, and the salary from employees, E, natural join, departments, D, that should be it. And let's see if we got our same results. And as you can see, we did. Now, many people would claim that's cleaner because we didn't need a where statement in there. The system was smart enough to realize there is a field called department number in both tables. It is of the same data type and it is of the same size. So there's a natural join right there. And a named column join, let's do one of those as well. Although natural joins can be handy for simple join operations, you might find that you do not always want to include every matching column as part of the join condition. The way around that is to use a named column join, which allows you to specify which matching columns to include. So again, I'll use theirs as an example here, base mine off of theirs. So again, we will select. In fact, let's just bring back up what we had just a minute ago. So we're going to select those. From employees, E. Join departments, D. And now we'll say using department number. All right, and again, let's see if we got that correct syntax-wise, and we did. So you've now seen close to a half a dozen different ways of creating join statements to combine information, in this case, from two different tables. And we could do that, again, because those two different tables had a field in common. Use the condition join. So far in this chapter, we've looked at comma-separated joins, cross joins, natural joins, and named column joins. All right. In that, then they say, what's this and what's this? The condition join takes an approach different from the ones we've looked at so far. In a condition join, the equijoin is defined in the on clause, which works very similarly to a where clause. However, despite the use of the on clause, it's similar in many ways to the previous joins we've looked at, except unlike the natural join and the named column join, the condition join allows you to match any compatible columns from one table against those in another table, and the names do not have to be the same. All right, condition joins can be separated into two types of joins. All right, inner joins and outer joins. The difference between the two is the amount of data returned by the query. An inner join returns only those rows that meet the equijoin criteria. In other words, only matching joins. All right, this was the original join available in SQL, often called the standard join. An outer join, on the other hand, returns matched rows and some or all of the matched rows, depending on the type of outer join. Now, to do this one, I'm going to do one thing. I'm going to insert into departments values, and I'm going to put null, and I'm going to put a new department in here. And I'm going to put billing. All right, so now when I select star from departments, I have 7 departments, including a billing department. But if I select star from employees, in fact, let's not even select star. Let's select distinct, which just says show me no matches, department number from employees. And notice I only have people who work in departments 1, 2, 3, 4, 5, and 6. I don't have anyone who works in department 7. That was done on purpose. All right. It says suppose you want to join the titles table and the artist table. Here we have an inner join that was created based on the title ID. So they use the on statement here. So I'm going to do a similar thing. Very similar again to what we've been looking at before, except I'm not putting in wheres. Okay. We can add a where. It doesn't really matter. We can do that. So we can select the first name. Looks here like they're qualifying everything again, so that's fine. We can go back and qualify. So E dot first name, E dot last name, D dot department, E dot salary, from, okay. Now we're going to inner join on E dot department number equal D dot department number. Now, I'm going to run this, and then I'm going to come back and make a change to it. So you see that works. And that's fine. So now we've done an inner join. All right? But let's make a change to this. Let's add a where in here. So let's do this, and we'll say where department number in, so I only want people who work in departments 1, 2, or 3. All right, where clauses. Oh, I'm sorry. I have to say which department number. So let's try that one more time. So I've got to say where, and it doesn't matter which one I use, but I'll say D dot department number in 1, 2, or 3. And notice I only get the people who work in department 1, or department 2, or department 3. Let's run that query one last time. But let's order it by E dot department number. And you notice I get just the people who are in department 1, or in department 2, or in department 3. The point is we did an inner join in here. That's the key thing. We did an inner join. All right? So, very similar to the one the author just showed. Now let's do an outer join. And notice there are 3 types of outer joins. I believe this is the last thing that we'll be discussing in this chapter. I want to just double check. Nope, we got unions to go also. And I want to check my time. Oh, I'm already at 24 minutes. I'm going to come back and finish this chapter up in just a couple.